we are creating circulation. All right.
Just the lemon. Oh, just the lemon. Because the banana can blow it up and just be.
When did banana?
I know, but they're already almost sweet enough. They're just growing sweet.
Check on our thing.
Some of them decided to get up and do this current.
Yeah, some of them are cooperating.
I think you need like 5 tea lights.
I might go fetch another one just to add some more to the situation.
Or maybe don't let them cluster. Maybe they're holding each other down.
Well, they might be holding each other down, that's a fact.
Clearly, we could pull it out.
What was that about Hallie's planet? When was that coming around again? Or what was it? That
Doesn't it get
very
closer
rare
and
one.
closer?
Haley's Comet? Hal Bach or something.
It might come and enter the atmosphere.
Yeah. Why are we gonna know?
Mr. Kent, what was that comet that came a while ago and it's not coming back for however long?
Haley's Comet?
Yeah, but there's another one that's not even coming. It's called.
Like Haley's Comet is like every 8 years or something.
The other one that was like 2
What about
million.
Hale Bach or something? Laughing.
The which?
Hale Bach.
The Hale-Bopp Comet?
Yeah.
No clue about that one. Well, look, we are getting more rising.
Is Haley's Comet gonna come pretty soon?
It goes every 80 years, and it was about 15 years ago.
So people,
How
some
much
people
is it?
don't
Probably
even,
like 70 something.
some people don't even see it or like.
Those are that's definitely working. That's really cool.
Ah, shoot.
I saw it last time. It was just kind of fuzzy.
How
Was
long
it-
was it there?
Huh?
How long did you see it?
It was there for like a week.
For like a week.
Just traveling through the sky. Does it go fast? How fast did it go?
Not really. All
Did
right.
it burn up?
Well, eventually comets do wear away.
Disintegrate?
They disintegrate.
Oh yeah, Comet Hale-Bopp, which has reached perihelion in 1997, has one of the longest recorded periods, 4,000 years.
Yeah, you're not going to see that one.
That was like I've hardly a chance, hopefully.
Yeah, right.
This is an invasion of the world.
Do you guys want to see my experiment? Come here and look at it. See, we heat one edge of this bowl, and the water very slowly comes up and moves over and goes back down. It's going to come back around eventually, hopefully. Unless it doesn't.
You look so confused.
It's because of the way.
You know how you said if
We're
you're
being
sucking
cautious.
a
The
cup,
tires are big.
like, and the water comes.
Yes.
What if you know those big commercial things that you milk a cow with?
Mm-hmm.
How would that work? Like it's still
Well,
sucking
it's
on it.
flowing from an area of high pressure to an area of low pressure, which is the question today. That is actually on our list of things to talk about. But first things first, we will check.
Good.
We will start. Did the quiz. I believe. 7.2. Is that correct? Start with quiz. That's quiz 19.
Are we rating these two together?
Yeah, we're gonna run this together. Number 1 is C. Second didn't have. Number 1 is C, 2 is B, 3 is A. C, D, A. Number 4, radiation. 5, insulation. And 6, greenhouse effect. 7 is true. 8 is solar wind. Okay, maybe get off my table so we don't get wax and water all over everything. Yeah, don't want you to lean on too hard.
So what's 8 again?
8 is solar wind.
And what was 7?
True. 9 is true, and 10 is water pressure.
Wow.
Go to
Yeah.
90.
So if you get one wrong, it's a 90.
We're lumping that together with the 7.2.
Why? If you got there, it's cold. I know, but if you don't,
Yeah, 100.
normally I don't, and then it just wrecks my 100. I
That
have
is
one 50, 60 pence each.
I unfortunately can't really do that. It winds up being a percentage, and that's not how percentages work. All right, so number 1 for in 7.2 was radiation. 2, any 3 of these: cloudy weather, length of daytime, the angle of the sun's rays, and Earth's distance from the sun. And then why does the Earth not lose its heat as quickly as the moon does? It's because some of the atmospheric gas effects as a blanket, or you have the greenhouse effect that also works.
Okay, so for 2, I have cloudy weather, length of day, angle of sun's rays.
Yes, you only need 3 of those. So 3 of the 4, you're good.
For number 3, I had greenhouse gas.
That'll function for now. 4, which warms up slower and holds heat longer, water or land, and that's water. 5, convection currents are currents set into motion by the process of convection.
No, I
Now, this
didn't
is
write the
technically
process of whatever.
just currents set into motion.
Yeah, so
I have heat transfer by moving currents in hot air.
Yeah, that's good.
So these are convection currents because it's getting hot here and it's getting cool here. That's actually still pretty chilly water. But you notice here that all of our papers move over to this side, so now we have to do is like go down and back up.
I think you broke the current.
Yeah, it's fine, I'll come back. There was just a tornado there for a second. And then 6, the diabatic, which the diabatic, A-D-I-A-B-A-T-I-C. Alright, so those are going to be worth 7.5 points apiece. Again,
How many points?
7.5.
Oh,
So,
I think I did. What do you get now? I have an 82. I got 70.
this one.
yes. So hoping you should go better than that.
89.
Yes, sir. That's not too bad.
I don't know if you can do that. Is that right?
Yeah, you got 2 wrong?
No, I got 3 wrong.
You got 3 wrong. No, that's not right. 3 wrong, you have to go 17, so you're supposed to be.
89 minus 7. 89 minus 7.
So you're gonna get no 70.
Wait, I had 4 wrong. So that can't be an 82.
No, 4 times 7, 28. So it's
I said that my
I'm gonna have to curve this one a little bit.
calculation.
I would have got a better grade if I had lumped them together.
What did you say?
No.
Yes, but these are 10 points. And so that would give me a 90 on this. And so I get a 93 on both. And then I got 100 on this. If you average them together, it's a 95.
Okay. That's because you're averaging them. Okay, yes. But actually, it's fine. Okay. So, I may curve that a little bit. We'll see. I want you to put your name and date on those, put them together, and hand them to me, and I'll adjust them to Mr. Wolf if that's necessary. All right, circulating currents, which we have been talking about. So, what happens to a balloon when it gets cold? I looked for I had a pack of balloons, and for some reason they're gone.
They're white. They're right there.
Right where I left them, probably,
I
huh?
think he's going blind.
That's possible. I looked everywhere but there.
Did you put that salve on your eyes?
Yeah, let's stab. Hold on. No, it's too bad.
There's balloons everywhere.
All right.
I want more balloons.
First you see the richest, second we don't. All right. You didn't throw that out, did you? Did you? The last work? Because I needed it. Okay. All right. I needed it. Okay, perfect. All right, so here's the deal. When a balloon, obviously there's air inside the balloon, right? So I'll just go ahead. I'll have to demonstrate this without using the tools I was going to use. So we have a balloon, we fill it up with air. I can't make any funny noises.
pop.
All right. Well, we
That'd be
could
great.
make it pop.
Make it pop, make it pop.
Oh my
Make it pop.
goodness.
Make it pop.
Keep going down.
Keep
All right.
going. It's not really like that. It's
This balloon
It's like
is full of hot
It
air.
makes me uncomfortable.
I know that. It's provable. Because, well, you look at the source. So, it has hot air in it. As a result, I can't tie this off, that'd be illegal. Basically, that's one of the things that makes it large, right? So if you were to put this in an oven, aside from the fact that the oven would just simply break the skin of the balloon, if you were warming up maybe in hot water, just dump it in hot water, it would grow in size.
Yeah, let's do it, let's do it.
We don't have the facilities to do everything I want to do with this. If, however, I took liquid nitrogen, which I also tried to get a hold of and couldn't, and poured it over it, this balloon would shrink down to very close to half its size. The reason for that is because hot air expands and cold air contracts. So, pour liquid nitrogen over it, the air would go out of it. It would just get smaller, and the balloon would just do that. Alright? And then if we would warm it back up by dumping it in that cold water, we would get the old action going on. It would get bigger again. We would actually return to its original size. There are some limitations with that. Some of them are the fact that well, the rubber will pull out forever and eventually it'll just get an explosion.
Here, make it pop.
So, under hot conditions, bang! Can somebody bring those for me? Have you been raiding the teacher drawer again? I see how it is. It's out of there all the time. Introduce more hot air, and well, what that is. Hot air makes it bigger, cold air makes it smaller. All right, that's important. That is important because what that means is, as this hot air, as you get hot air, or for example, remember how we said that when the sun shines down on the earth, it absorbs, the ground absorbs heat, right? What happens is, the ground absorbs that heat and then it gives some of it back up into the air, right? So say for example you have a field or a parking lot, which is black, correct? That black parking lot absorbs, it has a higher or low albedo? Low albedo. And so it gets really hot. And then it gives a lot of that heat back up into the air. And so we get a patch of hot air that's going up. All right? Now this is an important thing to remember because this is going to show up again. So, we got hot air that's going up. This is an area of low pressure. All right? Hot air goes up, cold air comes down. Now, for example, because things have to work this way, we know here that our hot air is going up. This is an area of low pressure over here. Are we going to boil water eventually? We might. Boil water with things.
It's not moving anymore.
It's not moving anymore. I think our thing right now. Say what? So if you heat this side, what happens is we're getting a cycle of
What's the matter?
water. I think it's just too warm and now it doesn't want
If
to.
you push him.
Well, basically what happened here probably is that it started pushing too far over this way.
Why don't you push all the paper down and see if it...
We can. We use this tool because I don't know. Might as well.
Whoa, it's just like some
Hopefully,
paper.
it should still flow over to this side because.
Whoa, it is pretty fast.
All right. Yeah, it doesn't want to stay on the bottom anymore.
But it's water.
All right. So hot air goes up and creates low pressure. That's very important. If you have cold air coming down, which this is the way it works, what happens is, imagine taking a leaf blower, right? And you blow it at the ground. What's going to happen? You
All the
understand?
grass folds away.
Well, all the grass folds away from it. You know why? It's because the wind is creating wind. So cold air, when it's coming down like this to the ground, what happens is it creates a spot of high pressure. it basically piles up air and wind down here, and it has to go somewhere, so it just goes straight out from there. So this is why we get cold air coming from the poles. We get polar winds, especially in the winter. When it comes, basically, cold air coming down creates a spot of high pressure, and then you actually get some circulation like this as well. So it goes like out close to the ground and in toward the top. This gives a situation like this. You ever see a forest fire or just a bonfire where it starts picking stuff up, and eventually if it's hot enough it'll create its own wind and start fanning itself a little bit brighter because of this action right here. The air just kind of sits here and circulates and blows on the fire. So it goes out at the top, in at the bottom. Here, our wind goes out at the bottom, in at the top. All right. So, the Earth is not heated evenly. And we know that, we understand that. And this is another factor that causes wind. We know that when the Earth gets heat down here at the equator, right now, boom, gets heat down here, and so we get air coming up, and the air spins and goes like this, right? And it creates a wind that's blowing toward the equator. What that does is it also creates wind that goes, it creates a lot of funny patterns, which you can look on, we're not going to spend a lot of time on that, but you can look on page 218 and you can see kind of what the wind patterns do. Notice the air here that's called Hadley cells, they happen right here. Yes, sir.
That map ain't right. I've been to Egypt and it's not yellow.
Exactly, it's a line map. All right. Now we have to get into the Coriolis effect. Now, the Coriolis effect, I'm sure you've heard of, and you know that it affects the direction of winds, right? So when you have a tornado, we don't have tornadoes here.
How boring.
How boring is that? We're going to make one though. It's not today. That's on the slate for Thursday. We're going to make a tornado. Hopefully.
With water.
No fire. Water tornado? Are you serious?
Yeah, a water spout.
No one talks about water tornadoes.
That sounds more exciting anyway.
Yeah, absolutely.
Fire.
Well, we haven't done anything with fire yet, and we want to keep that,
We did too do stuff.
Anything with bigger stakes.
Actually, literally all of our experience have had fire in them. That's fine. I'm cool with that. All right, so the Coriolis effect is just this. If you would, for example, look at this. I'll be spinning this. You can look at this. We're spinning this approximately as fast as it's spinning in real life. In real life, the equator spins at about 1,000 miles an hour.
I thought it was 800.
It's I'm confusing me.
That ain't linear, 800,000.
Then it would stop.
It's actually-
Boom,
it's
we'd all
actually
go
pretty
flying through everything.
Is it
No,
because
1,040. I was right. The reason for that is because the Earth is 27,000 miles in circumference and has to make it around every day, every 24 hours. So 1,040 miles per hour at the equator.
So is
The
it
thing
windier
is-
at the equator?
Say what?
Is it windier at the equator?
No, not really. We're not worried about that right now.
You're
We're
spinning
talking
it as
Coriolis
fast
effect.
as the Earth goes right now.
What? Don't be putting
No,
words in
he
my mouth.
ain't. He's
All right,
lying.
so I'm spinning it 1,000 miles an hour here at the equator. The deal is, it's a lot slower wind up here. So say, for example, the Earth would stop.
Yeah.
We'd all go
And
flying 1,000
We would all go
miles.
out. No, we wouldn't,
We
because
would
we're
go
not
at
at
that
the equator.
speed.
So here's the deal. Where we live, approximately, let me think. I'm not going to make up the number.
You might
Yeah, I'm going to make it up. 700 miles an hour. Or 800. We'll go with 800. That's more impressive. Yeah, 700. So the thing is, because we're so far north,
520.
that's actually a little bit north of us. 520 is a little bit north of us.
Oh.
So-
900.
That's a little south of us. The deal is, basically, we are just moving at a little different speed. We're going around the Earth the same amount of times, but because we're closer to the axis, we're actually going at a different speed than down here. So, if the Earth would stop, all of a sudden there would be 1,000 mile an hour wind at the equator, because that's the way life would work. But up at us, it would only be 700 miles an hour. And we could probably
Still.
take that, obviously.
We would
Also, there'd be water that would just totally splash right over the Cascade and hit, so that's not a big deal. And the valley would be done. That's too bad.
We don't care about them at all.
That would be so interesting to watch. from
It would be
space.
interesting.
Oh.
I do not want to be involved in it.
Did you ever
Yeah,
see
that would be so
that
interesting to watch
documentary
it.
where that Mount St. Helens, they looked it up and it shuts on news? So they're predicting another big eruption. Not, I don't know if it's from St. Helens, but it's supposed to bring the water up to I-5.
Yeah,
What's
I
that?
remember that.
So here's the
What's
next
That was
It's a highway.
The
over the
They
highway.
don't
Did it do it?
know that.
I know.
you know how snipers.
Yeah, I heard that. too.
Snipers have to deal with long range shots, right? So we have a sniper sitting up here,
Okay.
and he's shooting south. He's trying to
Towards
get.
the equator.
If he's gonna sit up here in Russia, and she's gunning for Saudi Arabia. Right?
Oh my goodness, that's quite the shot.
Well, it is, but we have to use some big numbers here, right? So he shoots, and he shoots directly. He shoots directly at the bee here in Saudi Arabia. Now the Earth is still moving, correct? So when he shoots, everything is right here. His bullet starts going, and then the Earth turns, and he hits Egypt.
Whoops.
This is actually a factor when people are sniping. Now,
There's people. Wow, that's.
basically, if you are shooting north and south, you have to account for the rotation of the Earth. The reason is because the Earth will just
Basically, you
move underneath the bullet.
You just
Right?
shoot.
So you
to
shoot,
the-
and then the Earth moves under the bullet. Also, if you are shooting east and west,
But they're not shooting.
so you're shooting from here. Now you're shooting for.
Overshoot.
So right, you'll either over or undershoot, depending on the direction you're shooting. So now we're shooting from Morocco towards Saudi Arabia because everybody's picking on Saudi Arabia today. And we shoot, and hang on, we should the rotation is this way. So you shoot, and the bullet travels and travels and travels and tries to catch Saudi Arabia, and it doesn't. And it just lands in Egypt.
For Egypt.
I feel like Egypt is being targeted
All
now.
right. So this is part of the Coriolis effect. This is actually a real life example of Coriolis effect, and you actually have to start taking it into account if you are shooting over half a mile, which I don't.
Of
So
course, I'm going
yes, that's something to worry about. But it is an actual real effect, and you can calculate for it depending on the
First
direction you're
trial,
shooting.
and we look people.
I probably would have.
Snipers are supposed to account for the rotation of the Earth, but I honestly just shoot.
Yeah, exactly. Well, it all depends, and
Well, like,
honestly, some of you just don't have time.
so
Now the deal is,
if
the
you
closer
shoot-
you are to the North Pole, the less effect that has. Than if you're down here fighting in the Middle East or in Africa, that'll have much larger
Okay,
effect.
so if I was standing on the North Pole exactly at the one stop, I wouldn't go flying.
You would just be.
Right,
No,
you just get dizzy.
Probably would.
Well, a lot of things would be happening. You'd probably die.
Well, no, but hey, so if you're shooting in Russia and you're trying to hit Saudi Arabia, do you shoot toward east?
You would have to shoot
India.
high.
Oh, what
Yeah,
about
you
those
have to-
you
rockets?
shoot
What,
low.
how?
When
what,
you're shooting east, you have to aim high. When you're shooting west, you have to aim low because the bullet will catch it.
What do they do with rockets when they shoot off them?
Pretty much the same thing.
Like we do.
They aim way out in
No.
front or behind after.
Well, there's been a lot of traffic, and maybe if they could pick a side, that'd be great.
You want to sit
Just you can do
Last thing on the Coriolis effect.
either you stay in here or you stay up there. Okay?
What do we have?
Up your leg.
Air going up. All right. What happens is, what kind of air do we have that goes up? Hot air, right? So, yeah. So we have cold air up here, we have hot air down here. So when a cyclone or a tornado tries to happen, what happens is essentially, all that goes on is that the hot air just flushes through this layer of cold air up here.
Flushes up the toilet
That's
and down the
kind
toilet.
Actually, it's very, very similar to a toilet or to a
Hey,
bathtub.
that's something
We
to
don't,
say.
unfortunately, we gotta really rush along here. So this is called a cyclone, whenever the air goes up. All right? The thing is, what happens is because the Earth is spinning like that, and well, what happens is, so we have a spout of air just shooting up, and the bottom is turning faster than the top, because, well, that's the way it works. Because, so the Earth has some friction on it, so the bottom turns like this, or actually it goes like this, and basically it makes, that amount of difference in the spin makes that cyclone twist.
Does that make hurricanes and stuff?
That's why hurricanes and tornadoes twist as they go. And that's also why down in the southern half of hurricanes have longer tails, because that friction of the earth dragging them along is what actually,
What makes them start? Like what?
well, it tends to be this situation where we have hot air going on. Hot air and hot water feed a hurricane. This, on the other hand, so this is cold air coming down. This is something a little different. This is called an anticyclone, which you don't worry about very much. All right, but it's an important thing we have to talk about. Now, an anticyclone will spin the opposite direction of a cyclone. All right? And we know the Coriolis effect affects cyclones. They spin clockwise. Cyclones spin clockwise up north, which is just, that's just the way life works. They spin counterclockwise down south. Cyclones do. Now, anticyclones spin counterclockwise up north and clockwise down south.
Okay, so Mr. Kent, what happened in the cyclone just happened? It started exactly on the equator, wasn't it?
It would get confusing physiologically. I don't know.
If you answer your way,
I guess normally what happens is they wind up moving north or south, and then they wind up doing things. All right.
Can I leave?
Yes, please do.
You are no longer appreciated.
That's right. Underappreciated and
Air
underpaid.
flows from high pressure to low pressure. I'll
Is
take
that
some
fact?
payment. I mean, I come all the way over here every day.
There. Prepare your class.
I have to listen to it.
Why is life so hard? All right.
This creative writing thing,
Tell me.
what am I supposed to do with it?
or whatever you like.
Woo.
Can
Boy.
you repeat who we're supposed to add?
It's not making any sense
You're
because
not finding any.
2 teachers and 1 of you.
Three teachers.
but we can't do teachers.
You can do 3 teachers. Yes.
So we're just supposed to ask them, what do you think when you think of lost,
Yes.
tall, or red? And then write down what they think of it. And then,
Well, I mean, yeah, write down what you think of it, and then write an essay.
And then
Yes. Put it into paragraph form, incredible credits due.